Slide 1. In the name of Allah, the most gracious, the most merciful. Slide 2. The latest and most advanced state of artificial intelligence to date. Deep learning is a branch of machine learning and a subset of artificial intelligence that focuses on the use of deep neural networks. In this method, machines, inspired by the layered structure of the human brain, gain the ability to learn from large and complex data. Neural networks consist of multiple layers, each responsible for a specific task in the learning process. This technology is widely used in fields such as image recognition, voice recognition, language translation, natural language processing, and autonomous vehicles. The basis of deep learning is that machines, by receiving input data, identify hidden patterns and make decisions based on them. Developments. In 2006, Geoffrey Hinton and his colleagues introduced deep belief networks, DBN, which revived deep learning. In 2012, the AlexNet model used convolutional neural networks, CNN, in ImageNet competitions, creating a major breakthrough. In 2014, generative adversarial networks, GANs, were introduced, playing an important role in generating artificial data. In 2015, ResNet networks were introduced, enabling the training of very deep models. In 2017, the transformer model was introduced, leading to significant advances in natural language processing, NLP. In 2020, the Vision Transformer, VIT, model was introduced, transforming deep learning in image processing, and the emergence of large language models, LLMs, such as GPT-3 significantly impacted text generation. From 2020 to present, we have witnessed the development of multimodal AI models that can process and combine different types of data, image, sound, text, and advancements in AutoML for automating the process of designing machine learning models, as well as the widespread use of deep learning in edge computing and quantum AI. Current status. Deep learning has now become one of the most important tools in data science. Transformer models such as BERT and GPT have reached unprecedented accuracy in natural language processing. In visual sciences, models like VIT and diffusion models demonstrate exceptional capabilities in image recognition and generating new images. Additionally, deep learning plays a crucial role in various industries, including healthcare, finance, e-commerce, and energy. This technology is still developing, and new applications will emerge with further advancements. Although deep learning has made significant progress, there are still challenges. Need for large data. Deep learning models usually require large and high-quality data. However, methods such as transfer learning and self-supervised learning help reduce this need. Computational complexity. Running large and deep models requires powerful computational resources, which can be costly. Explainability. Deep learning models are sometimes known as black boxes, as their decision-making processes are not easily interpretable. Bias and ethics. Misuse of this technology can lead to unintended biases and even violations of human rights. The future of deep learning is based on several advanced trends: larger and more powerful models, development of models like GPT-4 in future generations that will have greater abilities in understanding and generating content. Multimodal AI, integration of multiple types of data, image, sound, text, into a single model to create smarter systems. Sustainable AI, focus on developing models that consume less energy and cause less harm to the environment. Personalized AI, creating systems that operate based on users' personal needs. And finally, impact on everyday life, from self-driving cars to home robots, deep learning will become an integral part of human life. Slide 8. Examples of AI growth indicators. These indicators have been collected from book materials and using artificial intelligence, which I present to you. Public sentiments. Public sentiment towards AI began in 1965 with a score of 30, based on a scale of 0 to 100, and has changed positively. This trend continued due to the practical successes of AI in various fields such as medicine, transportation, and e-commerce. In 2025, this score reached 95, indicating a high level of public trust in AI. Diversity in AI research and applications. Diversity in AI research and applications started in 1965 with a score of 10, based on parameters such as the number of scientists of different genders, scientists from developing countries, and the diversity of research topics, on a scale of 0 to 100. This score has continuously improved due to international organizations' efforts to increase the involvement of women, minorities, and people from various parts of the world. In 2025, the diversity score reached 90. Conferences. The number of conferences related to AI started with about 10 conferences in 1965 and has significantly increased. This growth occurred due to the need for knowledge sharing, the development of new technologies, and the importance of collaboration among scientists. In 2025, the number of conferences reached 800. Industries using AI. The number of industries using AI began with about 5 industries in 1965 and has significantly increased. This growth was due to cost reductions, increased AI efficiency, and the development of new technologies. In 2025, the number of industries reached 500. Internationalization of AI research and applications. The internationalization of AI research and applications began in 1965 with a score of 20, on a scale of 0 to 100, based on parameters such as the number of countries active in AI research, the number of international collaborations, and the number of joint projects, and has significantly increased. This growth was due to the development of Internet technologies, international collaborations, and the importance of AI in solving global problems. In 2025, the internationalization score reached 80. Human metrics. In the 2010s, AI helped improve performance in tasks such as chess, Go, and image recognition. This growth was due to the development of machine learning algorithms and access to big data. In 2025, AI performance in human metrics reached 1,000 units. These 1,000 units are based on performance in strategic games, image recognition accuracy, and natural language processing capabilities. Slide 9. Publication of scientific articles. The number of scientific articles in the field of AI started with about 100 articles in 1965 and has significantly increased. This growth occurred due to the development of new algorithms, access to big data, and the importance of AI in solving complex problems. Since the 2000s, with the emergence of deep learning technologies and neural networks, the publication of articles has grown exponentially, reaching 20,000 articles in 2025. Number of students. The number of students interested in AI began with about 50 students in 1965 and has significantly increased. This growth occurred due to the increase in job opportunities in the AI field, the development of educational courses, and the importance of this technology in the job market. In 2025, the number of students reached 10,000. Advancements in computer vision. Advancements in image and video recognition began with about 10 projects in 1965 and have significantly increased. This growth occurred due to the development of deep neural networks, access to visual data, and practical AI applications in various fields. In 2025, the number of projects reached 2,000. Processing and computing speed. The computing speed in AI began with about 50 computing units in 1965 and has increased exponentially. This growth occurred due to the development of GPU and TPU technologies and the optimization of algorithms. In 2025, the computing speed reached 10,000 units. These units refer to data processing speed, the number of computations per unit time, and hardware efficiency. Advancements in natural language processing. Advancements in natural language processing, NLP, began with about 30 projects in 1965 and have significantly increased. This growth occurred due to the development of models like Transformer and BERT and practical applications in translation, chatbots, and voice systems. In 2025, the number of projects reached 5,000. Thank you very much for your time. I hope I have been able to make a small contribution to AI education.